So across these basically like G-forces, thermal, and plasma effects, it's very difficult to simulate basically all three of those on the ground at the same time. You can do any one of those sort of individually to test out a particular subsystem, but if you want to combine all three in a flight-like environment, really the only way to do that is to re-enter at Mach 25 through the atmosphere.
All players, low down, active, bullseye, 1327. Post active. Lights on.
Okay, welcome to The Merge. We make sense of defense in an enjoyable way. Today, I've got Jake helping me with co-hosting duties, and as you know, we continue to stretch and explore some new topics. Today is definitely going to be one for the history books for us, because we're going to talk about drugs in space with a tech company. And to do that, Jake, why don't you go ahead and introduce our guest?
Yeah, our guest is Delian, the co-founder of Varda Space and a partner at Founders Fund.
Sweet. Yeah, thanks for having me.
Yeah, thanks for joining. Can you give us a little bit about your background?
Sure. Yeah, rewinding, back to college, I'd say I studied computer science at MIT originally back in the day, got tempted by the world of Silicon Valley and startups. And so ultimately ended up dropping out basically halfway through my sophomore year. Started my first company, which was in the, digital health space. It was like a workflow EMR tool for autism therapists. Originally got awarded the Teal Fellowship, and then also, went through, Y Combinator, and, built the company up to call it like ramen profitability and managed to raise a small seed round, but never really grew fast enough to be able to raise sort of follow-on financing. So after about 3.5, 4 years, we ended up selling basically to one of our clients. Then briefly had a little stopover at another startup called Teespring. I was the VP of consumer / growth there. And then now for the past sort of 6.5 years, I've been on the venture side of things. Part of why I originally got tempted into sticking around in venture is because I'd always had this long time sort of personal fascination with aerospace. And at least in, Silicon Valley traditionally, if I looked at my role models that had managed to have a large impact in space, it was people that had sort of made it big in like normal tech and then switched to aerospace. So anybody from like Jurvetson to Chamath to Elon, et cetera, all of them sort of follow that career path. And so I thought that was the only sort of career path that was available to me to have impact in aerospace, given that I wasn't that interested in being an IC engineer at SpaceX like some of my friends from MIT were. But then, at 23, 24, I realized, sort of because the barriers of entry had lowered so much in aerospace, I could instead actually go join, Vinod Khosa's firm, Khosla Ventures, and they would actually allow me to invest in aerospace, then and kickstart that sort of, career in aerospace, not just as an IC engineer, but getting to combine sort of technical plus business. And so I decided to stick around in venture. After about 2 years at Khosla Ventures, got recruited by Founders Fund, where I've now been for about 4.5 years. And I'd always had this particular thesis within, sort of aerospace around in-space manufacturing that I'd been really fascinated with. And it finally felt like it was time for that thesis's time to shine, let's say, in Q4 2019, when a Falcon 9 rocket launched and landed for the first time 4 times in a row, which to me felt like the sort of marker of, okay, reusability is no longer just a theoretical thing that they're doing a handful of times. This is now something that is going to massively impact, sort of launch economics. And so now is the time to start an in-space manufacturing company that will then get to coast off of increased, sort of cadence and decreased costs. And so originally, started off in Q4 2019, Q1 20, sort of exploring what is now Varda as an investment thesis. Ultimately, realized after 6 months, all the various players that I talked to, 30 plus different companies, just didn't have the right DNA or approach. And so COVID hits. I have a lot more free time on my hands, given that Peter Thiel basically told everybody at Founders Fund to, pause investing. And I realized, hey, I like building companies. Founders Fund is a place that likes to incubate companies. Here's this thesis that, I think can be, pretty impactful to the world and nobody else is really building. And so this is sort of the perfect confluence of factors to justify the, sort of extreme opportunity cost of, building a company. And so, in some ways, kicking, dragging, and screaming, realized that I had to start Varda. Otherwise, nobody else is going to.
Wow. Hold on. That's a lot to unpack for our listeners. So before we dig into Varda, I just want to highlight your LinkedIn profile says you claim you're MIT and it says degree dropout computer science. And I think you also had a plug at one point as the world's first space drugs and arms dealer on your LinkedIn profile.
Twitter bio, and it's still on there.
Oh, Twitter, your Twitter bio. Yeah. Okay. For those listeners, you're not listening to us on fast forward. He's been known to listen to his audiobooks at 3 times speed. I can't comprehend things at 3 times speed. So there's a lot to unpack there, though. Founders Fund, Y Combinator, Peter Thiel. Yeah, there's a lot of really good stuff there for people who don't aren't tracking. Those are kind of very good pedigrees in the investing, tech investing side. So as an entrepreneur and then as a investor, you're co-workers with Trey Stevens over there, co-founder of Anduril and a partner at Founders Fund. You guys are kind of walking the same path a little bit, huh?
Yeah, obviously, Trey's had a lot more, sort of success, than I have, but, definitely he's been a, sort of significant inspiration and mentor. I don't think Varda would exist if not for sort of pre-existing proof of somebody being able to relatively recently incubate something within Founders Fund while continuing, sort of to invest. Peter had obviously incubated Palantir back when the firm was first started. Effectively, it was an incubation, but, since then there hadn't really been anything, and that was, in roughly 2003-4, versus, Anduril was in, sort of 2016. So there's sort of a 13-year gap versus sort of since we incubated Anduril. There's now been a relatively consistent pace of Founders Fund partners incubating companies. But yeah, very much so. Have learned a lot from Trey and the sort of whole team at Anduril. Obviously, we're a distinctly different company. They are sort of trying to make a next generation defense prime and sort of defense first. Versus I would describe Varda as sort of the classical dual use where we pursue both markets and we generally only pursue defense markets when it's something that perfectly aligns with the pre-existing commercial roadmap that we have.
Yeah, and we're going to get into that because there's a fascinating overlap in your story. And you mentioned it, something about pharmaceuticals and medical, and you kind of put that on pause, and then COVID hit because you co-founded Varda. So tell me how you met your co-founders. What's the backstory there?
Yeah, so, rewinding, so Q4 2019, I started pursuing Varda as an investment thesis, and I'd been familiar with some of the companies in the space for quite some time, given that it was an area that I was really fascinated with, but it was the first time where it really made sense to, sort of aggressively go and meet with everyone. And so I spent about 6 months basically meeting everything from researchers within top 20 biopharma that had published research from the ISS, companies that had started to support some of those researchers, some of the independent companies that even raised some venture capital to try and tackle these problems. And yeah, after about 6 months, unfortunately came away with the realization that because the sort of historical launch costs made it so expensive, everybody had only operated in space manufacturing inside of a government-run station, and all these companies had sort of built, let's say, habits, economics, sort of customer use cases, and internal, sort of team DNA and culture, entirely focused on that, where their sort of only muscle that they had was how to operate within the ISS, how to operate with NASA funding, and how to publish scientific papers versus bringing actual sort of products to market. And so I basically sort of visited the last of those companies literally like third week of February 2020, right before COVID. I think it was literally my last sort of airplane trip. And then when COVID hits, Peter Thiel went into sort of a pretty bearish mode, and so as a fund we decided to really stop deploying for about 6 months. And so I had a lot more free time on my hands. And in May 2020, one of my very close mentors and a general partner at Founders Fund, Keith, our boy, sort of took me out on this whatever distance outdoor hike, and we're kind of asking him like hey, what the hell should I be doing with all my free time? Like, I don't know what to do when I don't have a job. I'm somebody who's sort of highly ambitious and likes to be as productive as possible. And his feedback was like, well, Delian, you work at a firm that is open to incubating companies. You've built companies before. What better time than right now, where you have a lot of sort of mental free space, than to sort of build a company? And I remember replying to him saying, if there's one thing that I learned from my first company is I should only start things in spaces that I'm extremely, passionate about. And the only thing that I, have a deep passion for, is aerospace. Unlike, my first company, Digital Health, which is a fascination of mine, but I wouldn't call it, sort of a lifelong passion. And ultimately, I think that's part of why my first company didn't work. And so I told him, I was like, well, if I were to build something, it would be an aerospace company. And then the moment that I said that, the next thought in my head was like, well, I wouldn't just build a random aerospace company. I'd build the thesis that I believe in the most that nobody else is tackling. And so I was like, well, I'd build an in-space manufacturing company. And so that was roughly May 2020. And that is what then, sort of sent me on a journey basically that summer of going from, oh, I should go do this to, oh, crap, I need to go to do this. And so I basically spent sort of the next 3 months kind of ideating, figuring out maybe some of those people that I chatted with in the past, would any of them sort of make sense as co-founders, and then also thinking through what would the sort of ideal core DNA of the founding team look like. And I realized one of the things that I'd never really thought about was what would be the infrastructure necessary to operate an in-space manufacturing company independent of the ISS. Given that that was the whole core thesis, and that was the DNA that I found lacking in any of these pre-existing teams, I had this sudden realization where I was like, oh, that's actually the DNA that I need to focus on a lot more in the founding team, more so than like finding somebody that's worked on this problem before. And ultimately, if you think about what does it take to make a free-flying manufacturing satellite and the skill sets that are necessary, for that, one part of it is for sure just sort of the standard skill set that you see in something like a Starlink, right? You need somebody that can manufacture, satellites, radios, solar panels, batteries, RCS thrusters, torque rods, etc. But the one part that was particularly unique about the business model is you have to return things back from space. So that means that you would need to ideally make a very low-cost, mass manufacturable reentry capsule. And so as I started to think through, well, who would even have the DNA for that? The only sort of commercial reentry capsule at that time that had been built pre-Starliner test at Boeing at the time, it was only really SpaceX. And so I had this sudden realization where I was like, I can definitely find in-space manufacturing co-founders, but I really need to find like a reentry co-founder, and that reentry co-founder almost certainly needs to be the CEO. Now, thankfully, having gone to MIT, I had a lot of friends that had gone and worked at SpaceX. And so I then spent most of, sort of July and August of 2020 mining through that professional network, basically asking people who in their network had worked on Dragon, had leadership experience from SpaceX, but also had, entrepreneurial instincts. I explicitly had learned from my first company that I'm not the right, sort of CEO for a business. I think I'm a great president, chairman. I'm good at fundraising, public comms, but there's a lot of the CEO job that I don't think I'm great at. And so I would need a co-founder that like knew what a Series A was already. I'd obviously would know a lot more about a Series A than they would, but I can't be like totally teaching them from scratch. Pretty consistently, the sort of top of everyone's list was my now co-founder, Will Brewy. And so finally met him third week of August after trying a few different ways to get in touch with him, pitched him on the idea and why I thought he'd be the perfect CEO. And it didn't really take much convincing. I think even he had the realization he never thought about in-space manufacturing, but I think he quickly realized, right, this is the exact type of business where you want engineering leader that has re-entry experience and is entrepreneurial. And it turns out, if you're a CEO that is world-class in those sort of three things, the best business you could possibly build is an in-space manufacturing business. So that was effectively how I met my now co-founder, Brewy.
I remember when you posted a bar napkin picture on Twitter of a reentry capsule, and I think I DM'd you. I said, "Are you making Z-Bland? Is that the idea?" And I guess I was close, but I wasn't quite right.
Yeah, in the grand scheme of things, we did, we were always thinking about what is the long term of this, business, and it was obvious even from the earliest days that biopharmaceuticals were just like the highest margin physical product, the most revenue per unit mass, and that's obviously the biggest constraint in space, and so it was the place that had the most scientific proof on the International Space Station, so it was the natural place to start. But in the early days of the company, we did not think that a top 20 biopharma, given that it was unlikely you were going to do this fully from scratch and bring drugs to market yourself, you need to work in partnership with top 20 biopharma. The likelihood that they would sort of pay a lot of attention to a band of thieves seed stage aerospace company was pretty unlikely. And so when we actually started the company, the sort of like roadmap and path that we pitched to investors was like, hey, we're going to start off in fiber optics, which is explicitly sort of lower margin, a smaller market than biopharmaceuticals, and then over time, as we sort of gain traction, momentum, and proof points, and it can actually build into a larger company, we can then build the muscle for interfacing with larger enterprises like biopharma. And what ended up happening, and we can obviously dive into this more, was that about 6 to 8 months into the company, we had this realization where this dual-use defense use case around re-entry hypersonic testing was going to be a much nearer-term market in terms of revenue recognition and much better unit economics than fiber optics was ever going to be, and it was large enough that it could allow us to get to scale where top 20 biopharma could take us seriously, and we could afford to build out more of a biopharma both technical and BD team. And so Z-Bland and fiber optics was the original plan for call it like the first sort of stepping stone, hot swapped out by this dual use defense use case, and that allowed us to much more quickly go to that end vision of biopharmaceuticals. So you were right at the time, but I was wrong in how things would play out.
What is the name Varda? Where does that come from?
It's funny, there's been a handful of times in life when I've had to come up with a name for something, whether it be, pets or projects or, names. And sometimes it takes, months or years to figure out the right name. And sometimes it literally comes to you in like less than 10 seconds. So it's funny, as I was working on this, finally in August 2020, it was like starting to, mature. I think this was maybe about a week before, I was getting introduced to my co-founder. So I was pretty committed at that point that I wanted to do it, but was still sort of looking for the right people. I thought about, what would the ideal name, sort of this project be? And I thought I'd, sort of stick to the historical precedent of Lord of the Rings themed names, partially because there, was some precedent in any incubations at Founders Fund that weren't Lord of the Rings named, did not work out too well versus, sort of Palantir and Anduril did. And so I thought, sort of why tempt fate? So I've never really watched Lord of the Rings. I've never read any of the books. So I was like, okay, let me figure out, what would I, possibly name it after? And so I literally just Googled like Lord of the Rings, space, cosmic manufacturing. And the first thing that popped up was Varda, which is this elvish queen queen that's in one of like the appendix books or auxiliary books. It's not in like the sort of main genre, but she's this elvish queen that is known for basically using the morning dew to manufacture the stars in the sky. And so I was like, oh, that's perfect. Like she's literally she's manufacturing stars rather than fiber optics or pharmaceuticals, but like close enough. And then I went to GoDaddy and the .com was available, and I was like, cool. So literally from like I need to name this company to knowing that the .com was available and knowing the name was like I think approximately like 35 seconds. And then we bought the .com I think like 2 or 3 weeks later once we had decided on the founding team. That was the original impetus for the name. And then you've got me wearing my today I'm wearing actually the old school logo. This is our logo for the first 3 or 4 months before we could afford a graphic designer.
That was not a planted question. I had no idea where that was going to go. So that delivered. That was great. I had no idea.
If it had been 2023, it would have been like at least 50% more efficient because you just would have used ChatGPT to come up with the name, right?
That's true. It'd be interesting to actually go through and see if I'll maybe do this right after this call and see if I prompt ChatGPT in the same ways that I prompted Google, whether or not it actually comes up with the name Varda.
For the listeners, if you're watching us on YouTube, there's a picture here I'm going to put up of what this capsule looks like. The best way that I could describe it, looking at the pictures online, it's like a subscale, like Apollo reentry vehicle type capsule. Is that shaped about right?
Yeah, we explored a variety of different, outer mold lines for the reentry capsule. Ultimately, we ended up deciding on the mold line that you're sort of representing, which is this 45-degree conical shape. It was a combination of both, some data from the Apollo days as well as Stardust, which is one of the more recent or the most recent, let's say, NASA asteroid sample return mission that had a relatively similar outer mold line, and so there was some reentry data around that.
And it's about like a meter across, something like that, 3 feet diameter?
Yeah, it's about a meter diameter. It's basically like a half sphere on top and then a cone basically sort of underneath. And so the diameter of both the sphere and the cone are a meter. It roughly weighs 90 to 100 kilograms, basically wet mass. So that's sort of fully loaded up with payload, pharmaceutical ingredients, etc., of which about 40 kilograms of that is pharmaceutical ingredients.
So for those of us who are on the Imperial system, if we do the conversion, that's like, what, 220 pounds? Something like that?
Something like that. I admit I have not thought about the Imperial system in a long time. At least in relation to aerospace.
So I think it was interesting you said that you got your inspiration when you saw the Falcon 9 do its consecutive land and reuse missions. Your capsule that we're just describing was launched on a Falcon 9 rocket last month, right? It's in space as we speak. Is that right?
Yeah, it's been cool actually over the course of the company's lifetime. The sort of thesis that we predicated, both my career on, but then also the company on in some ways, was that sort of cadence and cost of reentry launch were going to significantly improve. And so when the company was started, Falcon 9s were launching roughly every 3.5 weeks. This year, on average, it's been every 3.5 days. My prediction for the end of this year is that we'll be at a run rate of every 2 days, and by end of next year, it'll be roughly sort of every day. And so it's been really great to see that thesis play out. We got to launch on a Falcon 9 rocket out of Vandenberg Space Force Base on June 12th, so about a month and 17 days ago. I think 42 days ago now. At roughly 3 o'clock in the afternoon. It was really exciting. I got to be there in Lompoc on the coast and watch her. I got a glimpse of, let's say, the rocket, and definitely heard the rocket.
Since it's in Leo right now and it's going to be coming back, we'll talk about that in a minute, but have you tried to plot the orbit and actually get out a telescope and watch your baby circling the Earth at 17,500 miles an hour?
That's, it's, I guess, potentially possible with a telescope. These things are definitely pretty damn small. There was an OSINT account that showed a 1 pixel, tracking image of us, and even showed us passing by one of the other satellites that was on the same mission as Falcon 9 with us, given that we had a relatively, sort of similar orbit to them. Yeah, I've not attempted with, my naked eye. It's a pretty small vehicle, and unlike the Starlink ones that are, in a train, so it's somewhat easier to spot since you have 15 of them back to back. Probably wouldn't be the easiest thing to spot.
It's up in orbit right now, and it is manufacturing Ritonavir as we speak. Is that true? And what does Ritonavir do?
Yeah, so it manufactured Ritonavir. I'm forgetting the exact date now, but it was a Friday right after July 4th. So maybe this is like Friday, July 7th or something like that. So it was a 27-hour manufacturing process, effectively crystallizing Ritonavir. We decided to use Ritonavir for the first mission as a demonstration because it's a relatively famous small molecule antiviral drug. It came out in the mid-90s as the first ever antiviral treatment for HIV. And after being phenomenally successful on the market for about 2 years, there's a sudden drop in clinical outcomes with patients. As the FDA came in to investigate, they discovered that there was a sort of net new crystalline form B, form 2, that had formed on the manufacturing lines. There was a far more sort of metastable crystalline form, and so it basically spread and took over, sort of like Cas9 took over the world. And the FDA ultimately had to recall the drug after 2 years and obviously billions of dollars of lost revenue. There have still since been sort of terrestrial solutions for Ritonavir in terms of filtering techniques to get back to that original, sort of form 1. And it's actually a one part of the two-part treatment of a Paxlovid, of COVID that's called Paxlovid. So it is technically back on the market today. Point being, we chose it because it had this very famous crystalline issue that if microgravity had been a commercially available solution in the mid-90s, we potentially could have solved, immediately and allowed the drug to basically, stay on the market. And so it was a sort of perfect marketing case study of, a lot of our customers are deeply familiar with the Ritonavir case study. They're familiar with basically why microgravity could have been a solution. And so it allows us to, sort of demonstrate with something that is, quite prominent. We also, interestingly enough, in some of our, sort of flight preparations in September, October of last year, did end up actually, discovering the first new form, crystalline form of Ritonavir for the first time in 24 years. Did get, some published, papers around that. And so this particular mission, rather than actually doing either of the form 1 or form 2, is explicitly aiming for form 3, the new form that we discovered, and, sort of potentially showing a net new form of Ritonavir. So it was about a 27-hour manufacturing campaign. The way you can think about it is you're basically taking something that is previously in a sort of powder, disparate, sort of discrete form or liquid form and basically turning it into a solid state form. For this first mission, I like to describe it as if you compare a biopharma lab to like a kitchen, you have a ton of different appliances there. This very first mission for sure is us just demonstrating a toaster with like some plain wheat bread and, toasting it. And over time, we for sure want to build the convection ovens and the blenders and a ton of other, appliances. But for this first one, we basically literally just like melted Ritonavir, cooled it down at a very particular rate, got it to crystallize, and then now we're looking to bring those, sort of crystalline structures back home. So it's not like a month-long, sort of manufacturing process. It was about 27 hours, which has already happened. And so at this point, we're actually just waiting to, re-enter to bring the finished goods back home.
The words that you strung together to describe it, it was like the most badass high school science project ever. We just threw darts. So we have a rocket sending a capsule up into space that's spinning around the Earth with a toaster-sized autonomous pharmaceutical lab that's using crystals and microgravity to build a HIV drug. Did I get all that right?
Yeah, that is all correct.
That's ridiculous.
When you make a new crystalline form of a drug, can you patent it? And do you need new FDA approval to use that drug as a treatment? How does it sort of impact the regulatory framework?
Yeah, so there are two different types of patents in relation to these types of net new forms. There's what is known as a form patent, which is the specific, basically crystalline structure, as well as a sort of process patent, which is basically how did you create that form. Now, specifically with Ritonavir Form 3, I did mention that we basically discovered this first new form for the first time in 24 years. Funnily enough, AbbVie, which is the current owner of Ritonavir, happened to have an internal research team that basically published their paper on Form 3 literally about a week before us, showing that they basically discovered the first new form as well. So they technically own the form IP. We did publish right after them, given that we pointed out some technical flaws in their paper. They had missed some prior analyses where there was actually a Japanese team about a decade earlier that did actually stumble across this form. They just didn't realize what they were looking at. They were confused. They were basically like, wait, this isn't Form 1 or Form 2. Something must be wrong. And so technically there is sort of prior art on both of us. And the process that Varda used to create that Form 3 was a more efficient process than what AbbVie had discovered internally. And so technically today, Varda does have a process patent on Ritonavir, and we're basically the only owner of IP on Ritonavir outside of AbbVie. And depending on obviously how this sort of first mission goes, if we do find a completely net new form, we may get form IP. If our process somehow yields something that's even more efficient in terms of results than what either us or AbbVie have done, we may get even sort of net new process IP. But that would all require analysis on the ground or over time. For sure, we want to get better instrumentation on board in the satellite. But for now, we definitely need to bring the pharmaceutical crystals back to study them. In relation to bringing the actual drug to market, it depends on drug. If it's something that's never gone through, if it's an NCE, so a new chemical entity, you still have to go through the sort of standard clinical trials. So a lot of the compounds that we're working on with partners that we can't announce yet are more sort of NCEs, more so than they are sort of live on the market drugs. If you're taking a live on the market drug and showing that you've created a net new crystalline form, for example, like what Merck demonstrated on the ISS with their monoclonal antibody biologic Keytruda, there you go through what's known as a 505(b)(2) process, where you're effectively just showing that is sort of bio net similar to the pre-existing sort of crystalline form. Effectively, that there's no sort of toxic effects and that you're getting pure beneficial effects. For example, like improved solubility or improved side effects or improved shelf life or stability. And so the burden of proof when you're basically reformulating is what it's called, or finding a new crystalline structure of a drug that is already on the market, the burden of proof is definitely far, far lower than a net new compound. But to date, Varda's engagement with top 20 biopharma is mostly on net new compounds, given that they're clinical drugs on the market are sort of the golden geese, and they're not quite willing to work with a more nascent platform like Varda on those. But over time, we expect that we'll also get enough, let's say, experience and get enough trust from top 20 biopharma where we'll start to work on live drugs as well.
I love that if you can't publish first, you publish second and point out all the mistakes in the first paper. That is 100% the way to do it.
It was a very funny 2 weeks because we went from like extreme elation of like, holy shit, we just found the first new form of Ritonavir in 24 years. And we like extensively studied. We found that one Japanese paper, but it was clear that they like didn't properly identify it. And so we were very sure that like, we were going to have this like groundbreaking paper. And then literally as we were waiting for basically like peer review, the AbbVie paper came out. And so then all of a sudden, like everybody on the team was like super depressed because like, oh my God, this is going to be our big break, because we were like thinking that before we were going to have to wait until flight to actually, be able to get any sort of real biopharma breakthroughs. So then there's like this extreme depression. And then as we were reading the AbbVie paper, we were like, oh my God, we have now since made, great friends with this particular researcher at AbbVie. So this is not at all meant to, sort of critique him, but we at least noticed a handful of flaws that we could point out that would then still make it a very compelling paper. And we noted that our process was still an improved process. So there was still going to be, some IP. So we were able to get that in the ACS journal, which is one of the most prominent, basically small molecule crystallization, sort of journals. So it was great that, we sort of went through this roller coaster ride over the course of, 2 weeks that we basically had to keep very secret because we can't talk about this stuff, given that until it's published and you have the, IP filed, you can't talk about it. But there was a lot of extreme emotions, let's say, during that 2-week process.
So Varda has their vehicle, their satellite in orbit right now. It just came out today as we're recording this that it's been delayed coming back, and it has nothing to do with NASA or anything. It has to do with the FAA, which I did not know until a few hours ago. Can you explain what's going on?
Yeah, we for sure have a few different partners, right? It's not necessarily entirely, the FAA or anything like that. There's sort of three major partners that we have to, get aligned in order to re-enter properly. It is both Rocket Lab, who are responsible basically for the deorbit burn, basically the rocket engine that brings us into the atmosphere and drops off the re-entry capsule. There's the FAA that both has to give us basically the re-entry license, so Part 450, this net new regulatory process that they've created, and get comfort with basically sort of potential hazards that are associated with our reentry, as well as within the FAA, the Air Traffic Control Office, ATO, that would basically need to publish some NOTAMs and TFRs, basically, rerouting some commercial air traffic to avoid our reentry. And then basically the third partner is the military range that we're landing at, the Utah Test and Training Range. So, we've engaged with, all three of these groups basically since the first week of the company and continued to collaborate with them to understand how we can bring this reentry capsule back. Sort of all three of them were obviously aware that, we launched the spacecraft, and that wouldn't have happened without their awareness and the FAA giving us approval to launch. And we're continuing to collaborate with them to get sort of the final sign off across, sort of all three parties in order to be able to reenter. But, Varda is definitely ready and eager to reenter as soon as that alignment has been.
So how does it land? I've been to the Uter before. It's rocky desert airspace in Utah where a lot of fighter training happens. So how's it going to land? Or what's it going to land on, I guess?
Rocks. Probably.
Okay.
Or dirt. It will land by coming in from space and ripping a parachute.
Okay. And then the toaster experiment has been successfully completed, and you have the telemetry coming back to Earth to show you, like, hey, it's all done. So when you open the capsule and your toaster's broken, it's not a big deal, right?
It is highly unlikely that the toaster will be broken, in that if you think about what's inside the toaster that needs to stay put, it's basically a bunch of what look like salt crystals. So if you think about it, even if salt rips 10 Gs or goes through a ton of vibration, it's still, salt. The biggest sort of risk to the toaster being broken is the thermal environment, so that the sort of salt melts back into a liquid. And the most difficult actually thermal constraint is not during the reentry process, given that we have an ablative heat shield, which by default basically pulls away the kinetic energy that gets transferred into thermal energy and gets pulled away and ablated. The most difficult problem is if the reentry capsule happens to land somewhere in the UTTR and it gets like stuck in a tree or like lodged in a canyon somewhere, or in a non-ideal sort of part of the base, and it takes sort of longer than, call it, 8 to 12 hours to recover. The sort of toaster sitting there on the desert floor in Utah in August can actually cause enough sort of thermal heat to potentially melt the crystals on board. The crystals are hermetically sealed from the rest of the vehicle, but over time there is still somewhat imperfect insulation. If the reentry capsule survives, which is also a question, it could just completely melt. But if the reentry capsule survives and the parachute deploys, it is unlikely that the toaster is going to be broken in half.
That's a lot of extreme heat, pressure, G's, destruction. Hopefully not destruction.
Yeah, the reentry capsule rips about 13 Gs, and the temperature experience at the surface of the heat shield is hotter than the surface of the sun. So it definitely gets through some pretty extreme environments, which is also why it's an interesting test bed for certain hypersonic use cases within the DoD. Because there's no humans on board, we don't have to worry about a comfortable ride on the way down.
So at reentry, it's traveling at about Mach 25. Is that right?
Yeah, roughly Mach 25.
And the sort of short-term revenue opportunity here for Varda, as you mentioned, is doing some hypersonic testing for the Air Force. Can you give us a little background on what that looks like?
I think the best way to explain it is through an analogy of, think about Boeing with their 747s trying to build, basically airplanes without a wind tunnel, where your only way of actually basically testing whether or not your design works is by going and flying the full design in a real environment. We probably wouldn't have as advanced of airplanes. A lot of what allowed airplane technology to advance was that we could test certain subsystems, wing shapes in an environment that was relatively net similar to what they would ultimately end up operating in, right? And that's why ultimately we're able to create some, really impressive vehicles at various speeds. Unfortunately, once you get above like roughly, call it Mach 10, 11, 12 or so, the ability to simulate a net similar environment on the ground effectively becomes impossible. The reason being there's these sort of three separate major effects that really start to amplify, especially since a lot of this stuff is related to either the square or the cube of your velocity, which is a combination of both. Basically, think of it as like G-forces. So similar to how in a 747 you feel turbulence. Obviously, when you're going Mach 25 through the atmosphere, if you experience some slightly lower pressure or an air pocket, it introduces sort of massive G-loads. The second is basically like the thermal environment. So as I mentioned, we experience basically the surface of the temperature of the sun at the surface, temperatures that are higher than the surface of the sun. And then the third is you're going so fast that you're actually separating the molecules in the atmosphere from one another. Think like nitrogen or oxygen, and you're actually creating positively charged ions that form that fourth state of matter, so no longer solid, liquid, or gas, but it's actually a plasma. And that plasma also affects the actual flight environment quite significantly. So across these basically like G-forces, thermal, and plasma effects, it's very difficult to simulate basically all three of those on the ground at the same time. You can do any one of those sort of individually to test out a particular subsystem, but if you want to combine all three in a flight-like environment, really the only way to do that is to re-enter at Mach 25 through the atmosphere. And so in summer in 2021, Varda was alerted to the fact that the Air Force was actually basically building an identically sized vehicle with an identical sort of outer mold line. We originally referred to this group within the Air Force as a potential collaboration partner so that we could learn from them about how to design a reentry vehicle, but we quickly recognized that basically this would be actually a very interesting revenue opportunity for us as a way to basically ride share our pharmaceutical clients alongside basically DoD that could basically just use separate parts of the reentry vehicle as sort of a testing mechanism, and the manufactured pharmaceuticals could ride on board. So, the way that I like to describe it is if the Wright brothers needed a, wind tunnel in order to test out their vehicles, as the United States is starting to build up and advance boost glide hypersonic technologies, Varda is effectively the equivalent of that wind tunnel. And so if you want to test out net new heat shield materials, navigation sensors, infrared sensors that allow you to detect adversarial hypersonic vehicles and, sort of guide towards them and, disable them. If you want to test out various wing shapes, these are all things that basically Varda can test at a much faster rate and cheaper than basically, anything else, and much more flight accurate relative to anything else on the planet, especially since we're going to be flying these things anyways for our pharmaceutical production. So it's been really great to see that message resonate. We, sort of stumbled across this use case very unintentionally in summer 2021, about 6 months after we started the company. And then especially in October 2021, when the Financial Times dropped the previously classified news about the Chinese demonstrating the first ever boost glide hypersonic missile, we had this sudden realization moment at the company where, whoa, we thought the fiber optics was going to be the stepping stone, but no, actually hypersonics is going to be the stepping stone. This is an extremely sort of near-term market for us. And so it's been great to sort of see the team here execute on that opportunity and go from identifying it to, at this point, a multitude of contracts across the Air Force, Navy, NASA, all for these sort of hypersonic and re-entry testing use cases. Definitely we see this as sort of the first piece of space infrastructure that the DoD and government parties are interested in, but we think there will be many more as we continue to pursue our commercial development roadmap.
So Varda was awarded a $60 million STRATFI contract from the Air Force. That's a strategic funding increase for those who aren't tracking. And that's basically a partnered money. So it's half is venture capital from industry, and then it's matched with the government. And I think that's between Air Force, NASA, and then AFWERX, who's the sponsor of your contract. But so you're basically a $60 million government contract. That's probably up there with the youngest company to get a STRATFI that I've heard of, at least.
I believe we are
recall.
the youngest company to have gotten, especially the full $60 million STRATFI by a decent margin. I think the next sort of youngest was about 3.5 years old when they got it. We definitely executed on it quickly. It was that we identified the opportunity at 6 months in, but it definitely took another 18 months to go from identifying it to getting it across the line.
But that's still, congratulations. That's a good feather to have in your cap. That's amazing.
Thank you. Yeah, no, credit obviously to the sort of team that we've managed to build here. Definitely takes a village. But yeah, super thrilled. And maybe to touch on for the listeners, the way that a STRATFI program works, as Mike mentioned, 30 million of it is actually our own venture capital dollars that we pulled from our Series A, and then the remaining 30 is government dollars, 15 million of which comes from AFWERX, the STRATFI program, and then 15 million basically comes from the end customers. And our end customers were several program offices that I can't name within the Air Force, as well as NASA. So it was effectively like 15, and then 30. And we've already begun, sort of execution on that contract. That contract was, signed and executed. I'm gonna say like late May or maybe early June, roughly time frame. And then we just had the first of the major milestones for that contract this past month, which actually made Varda net cash flow positive in July, which is kind of cool. It's kind of a fake metric, but it's kind of cool.
Take it. It's exciting.
Yeah, take the win when you can get it.
It's not free cash flow positive. It's not accrual cash flow positive or anything, but it is cash flow positive.
You mentioned China's hypersonic boost glide missile as being part of the impetus for the STRATFI and Varda's pursuit of a hypersonic testbed. As a private company, how much do you think about sort of the new space race with China and China-U.S. competition?
I said this, even on my Twitter, part of what motivates me to wake up every single day is to ensure that the primary language spoken on the moon is English, not Mandarin. And that has more to do with obviously the, let's say, political regimes within those two countries. I'd prefer for the moon to be a democratic republic rather than a genocidal dictatorship. Nothing against, I do love Mandarin. I took a semester or two of it in college, but I don't want Xi Jinping in charge of the moon. But ultimately, in order to get to that point, you can't rely on state budgets alone to create that type of sort of space infrastructure that's necessary to dominate in space. Ultimately, you need to create sort of commercial incentives. Anytime in human history you've had large-scale sustained infrastructure, it's been due to sort of economic incentives, not just due to sort of government and state budgets. And so that was effectively what Varda was founded under, is to the explicit one-liner mission of Varda that we've kept throughout the entire company's life is to expand the economic bounds of humankind. And there's two sort of core parts of that. One is the economic bounds, right? How do you take commercial activity from not just entirely, on the Earth's surface, but now take it into low Earth orbit, and in a unique way that isn't just using basically, radio communications, so, internet satellites like Starlink or Earth observation like Planet Labs, but something that, eventually will require sort of humans on board and can't entirely be automated. Our manufacturing stations for a long time will be fully, sort of autonomous. But if you look at like biopharma manufacturing on the ground, even though you have many facilities that are fully automated, still, even the best machines, once every 6 months, 9 months, once a year, require a human to come in and do maintenance, versus business models like Starlink or Planet Labs can pursue their models for a very long period of time without ever, sort of having humans on board. And so the goal is expand the economic bounds and most importantly of humankind. And so for sure there will be no humans on board Varda stations in the next 3, 4, 5 years. But over time, as we go from manufacturing satellites that are hundreds of kilograms to thousands of kilograms to tens of thousands of kilograms, eventually the marginal benefit of having a human on board that can actually help with maintenance, this robotic station, ends up being far greater, basically, than like the marginal cost. And ideally, Varda will be the first company in human history to send a human to space that actually generates more economic value than it costs to actually sort of have them up there, which is obviously not true today of any sort of astronauts or any of the commercial tourism that people are talking about, which is mostly a fake market. None of those are true, versus I think Varda is that first use case that could be true. And if Varda is then successful, that is what then has downstream implications that enables business models like asteroid mining, like lunar ice mining, that then allow us to establish dominance against the sort of Chinese in those domains. And so yeah, it's obviously a space that I'm deeply passionate about. And while it may seem that Varda is somewhat orthogonal to establishing lunar dominance, I'm actually pretty convinced that the best way to beat the Chinese to the moon is to beat the Chinese to commercializing low Earth orbit.
There's a lot there. A lot of big shots you're calling. I love it.
Right, so
great.
far.
Yeah.
You started something with Jacob Hellberg, author of The Wires of War, great book, highly recommend it, all about the tech competition with China. You started something called the Hill and Valley Forum, is that right? Am I getting the name right? Can you talk a little bit about that and what your goals are?
Yeah, so the obviously defense tech community, I think, has really expanded, over the last decade. Really originally, honestly was kicked off in some ways, or re-kicked off. Obviously, if you look at the history of Silicon Valley, it was sort of deeply integrated with the defense community, but I think lost its way for quite some time, especially as we got into this world where we thought it was the sort of end of history, and turns out that's not really the case. But anyways, sort of the reintegration between Silicon Valley and the defense community was obviously kicked off by sort of Peter and Palantir in 2004. Continued to be accelerated by companies like SpaceX and Anduril, but then especially in the last 3 or 4 years, feels like it's sort of really gone mainstream, where it's no longer just billionaire founders starting these types of companies. It's a much wider swath of people tackling these types of sort of national security problems within the lens and culture of Silicon Valley. And so Jacob and I realized that there was a large enough community now finally, and enough interest from both policymakers and acquisition officials within DoD. There needed to be a place where you could actually have a gathering of these, where if you tried to do something like Hill and Valley Forum 5 or 6 years ago, there just wouldn't be that many policymakers or that many founders that you could basically sort of invite to it. But for the first time, there was enough of a critical mass, but we felt that there lacked a stage that you could bring sort of all of those folks together into one place. And so we ultimately decided to run a first sort of beta version of this in September, October last year in 22. We're really happy with the results, and then decided to scale it up some amount in March of 23, and really happy with how that went. I think we got 20 plus elected officials, 100 plus defense tech founders, CEOs, VCs, et cetera. Both Peter Thiel and Vinod Khosla, gave basically opening remarks alongside Speaker McCarthy. Really, really happy with how that went together, and expect to do it on an annual basis, themed after whatever is sort of top of mind for Silicon Valley and DC at the time. So in that particular moment, the night before, we happened to be doing the dinner the night before the TikTok CEO was going to be giving his testimony in front of Congress. And so we kept it very sort of TikTok and China themed. Obviously over time, as sort of different issues percolate into these communities, we may sort of alter the theme, but we think we'll be sort of running this on an annual basis, and found to be sort of very productive across all sides. Policymakers sort of finding both companies that represent sort of their interests and the things that they want to pursue, but as well as a meeting ground for policymakers where in some ways in the post-COVID era they don't get that much time to spend with one another and realize, hey, there's actually a couple of other congressmen interested in the same issue, and we can align and not feel like I'm the only one sticking my neck out on the line when trying to get a particular bill across the line. And then same thing with the acquisitions officials, feeling really confident that sort of the companies that they're betting on have the backing of Congress, have the backing of venture capitalists that can help co-fund some of the projects that they're sort of pursuing. And so yeah, really proud to have been a part of it with Jacob, and look forward to doing this on an annual basis.
Yeah, sounds like a great event.
Jake, was that FOMO? Was that a little bit of FOMO there? I saw you kind of lean back.
It is FOMO. I didn't get to go, so I feel a little FOMO. I wasn't invited.
I can sense that.
Yeah.
I thought we invited you. My bad.
You invited me to the first one. I didn't get an invite to the second one. See, that's what happens when you can't make the first one. You fall off the list.
That might have been it. Yeah, maybe because you didn't attend the first, we didn't send you the invite for the second. So
well, it's not because I wasn't interested. So next, for the third one, I'll definitely
get you for the third one.
All right.
Well, that is a good pivot to your other job, your other full-time job. In defense tech and out in the Valley, what are some of the other things that are of interest to you right now that are really exciting?
Part of why I'm so grateful to work at a platform like Founders Fund is that they're heavily encouraging of or supportive of incubating companies, especially in areas where you have a strong thesis around that you can continue to invest around beyond just the incubation. And so, a part of my sort of pitch to the firm around incubating Varda was, hey, sort of having a venture capitalist in this type of capital intensive company is going to be highly valuable. And so I can have a huge sort of impact here relative to just like investing in an in-space manufacturing company. But then two, I've sort of predicated my whole career on, betting on this particular wave around aerospace where, sort of decreasing launch costs, increasing cadence is going to enable a lot of business models. And what better way to make sure that I'm at the forefront of deal flow, founders' top choices for who they want to work with than starting one of the most interesting companies in the spaces. And so, I think that's played out quite well where I can now point to a multitude of investments across, sort of aerospace defense where the founders have, sort of proactively reached out to me and wanted to work with me given the sort of, pre-existing experience and the track record of, Varda to date. So I probably, in my investing job at Founders Fund, I probably spend about maybe 30%, maybe 40% of my time or investment dollars in the aerospace field. So it's not, 90%. And then the remaining 60% are very disparate across financial services, insurtech, consumer hardware like the aid sleep. So definitely wide, sort of wide range of interests. Within aerospace, it's been interesting, to see, and I'd say, obviously, if you're wondering about defense, I think Trey is obviously, sort of much more educated on that. But at least within, the aerospace part of defense, or generally aerospace, it's been interesting to see the Founders Fund ethos on investing in that we invested a lot in the, call it 2008 through 11 era, where we were, heavy investors in SpaceX, Planet Labs, some of the like sort of generation one companies, and then we effectively went on pause for almost like 8-9 years. And I think a part of that was there were no other interesting business models other than basically like launch, internet communications, and Earth observation. Nothing else really made sense to invest in at the time. And then now that you have this like generation one infrastructure, there is a second generation of companies that are worth, investing in. And we've made our sort of handful of bets that we're looking to make into companies like Varda, like Hadrian, which is creating basically automated aerospace machine shops, like Impulse, which is creating basically orbital transfer vehicles, and, one or two other sort of currently unannounced names. And, in some ways you may see now Founders Fund go on another basically like 8-year pause, because as much as we are excited by things like lunar ice mining or asteroid mining, we don't see those as being basically commercially relevant today. We think those are the types of companies that when the now generation 2 infrastructure gets very well built out, those probably sit within generation 3, right? If you look at Varda, there were equivalent companies that were founded in the 2010-11 timeframe the Founders Fund didn't invest in because the business model of Varda in some ways just did not make sense sort of back then. And so, I definitely look forward to one day investing in asteroid mining and lunar ice mining, but it's more likely that that happens, let's say 8 years from today versus, happens today, given that that's when we think it'll be the appropriate time to commercialize. So, I think we've made a lot of our, sort of most exciting bets in aerospace already to date, and you'll see us mostly doubling down on those versus making a lot of net new ones. And then, beyond that, like I said, spend a lot of time investing outside of aerospace as well, and find that, there's just lessons to be learned in a lot of industries that help apply. And I'm definitely starting to obviously get more and more intrigued by the biopharma world, given that, through Varda, I've gotten to learn a lot about it, or had to learn in order to, make the company, sort of survive. And so I'm hoping to spend a little bit more time in terrestrial pharmaceutical manufacturing type technology and investments.
Awesome. We're getting a little short on time. Jake, you want to take the reins here for a little lightning round?
Before lightning round, I think we should address the fact that, Delian, you just got your pilot's license. Is that right?
Yeah, it was about like 2.5 weeks ago now, and then I had to get my high performance endorsement for the plane that I wanted to fly. And this past weekend, I actually flew 12.5 hours total from like Thursday afternoon to Sunday afternoon. So quickly got excited and flew a lot of hours.
Where are you flying out of? Miami?
For the summer, I'm here in Los Angeles as we're operating our first sort of spacecraft mission. So the plane is actually based out of Torrance, and then on Labor Day weekend, I'm going to go fly across the country.
Well, congratulations on your pilot's license.
Thank you. Yeah, it's great to take to the skies. I think we have at this point, like 5 or 6 pilots at Varda, including my co-founder. So it's definitely a shared passion amongst several of the team members. And it's always fun when we're flying in for Air Force meetings, and the Air Force generals all come in on commercial jet airliners, and all the Varda, engineers come in on our own little planes. It definitely, I think, makes the right impression on who they're entrusting for the future of, hypersonic technologies. It's the right group of space cowboys.
Good first impression.
Yeah.
All right, quick lightning round. So these will just be a few questions, not yes or no necessarily, but pick one of 2 options. All right, investor or founder?
Founder.
All right, Elon or Jack?
Elon.
All right. The least favorite bestie on the All In podcast?
Oh, Jason.
Oh.
Oh, I can't stand sacks, but all right, Jason. Fine.
Oh, come on. Yeah, unquestionable. Sorry. I mean, Jason, I love you. Definitely my least favorite.
Well, he does have to talk the most. You know, he's leading the gaggles. So
Yeah.
I mean, I give him a little bit of a pass for that.
That's right. He's got to moderate.
Yeah.
That's fair. That's fair. All right, fly a fighter jet or fly in space.
Flying space. Tough call, though, but flying space.
You could have picked the U-2, and then it's like kind of both
Kinda
at the same
halfway.
time. I don't
Yeah,
know.
yeah. Or the, oh my gosh. What is the, I should know the name of this. Wow, I'm blanking. What's the space plane? What the heck is the space plane?
Is it
Like
the X-1B?
Oh, yeah, the X-1B. There we go. Yeah, the X-1B is what I really should have chosen. Just a little bit of both.
Yeah. Oh, that's pretty sexy. All right, Ukraine. More or less support?
I'm generally on the side of, yeah, more support. I think I subscribe to the, Truman philosophy.
All right, and then Miami or LA?
Miami for everything but aerospace, LA for aerospace.
Oh, that's a cop out. That's a cop out. All right,
So-
last
So
question.
the weather is better in Miami
Oh,
than
yeah.
LA?
Oh, my God. So much better. I can't stand LA gloom, like June gloom and the dryness of the, air here. Look, I'm a Bulgarian, born and bred, 99.9995%, whatever, 5,000 years of genetic optimization for living on the Mediterranean Sea. I'm meant to live in hot, humid weather with delicious feta cheese and tomatoes. And let me tell you, that is not Los Angeles, San Francisco, New York, or anywhere but Miami in the United States.
The air quality is definitely better in Florida than it is in LA. I'll give you that.
It's also thicker air, which makes it a lot more, fun to fly.
Last question. This one's a tough one. Teal or Rabois?
That's a tough one. At the end of the day, yeah, obviously, Red Boy. Yeah, got to stay true to the true original mentor.
Both Titans. Both Titans.
Both Titans. Both have been hugely influential in how I think about, sort of building companies and life philosophies. But Red Boy's been the, sort of stronger one via osmosis.
Nice. Good answer.
All right. Well, that's it for the show. Almost. Before, if you're still listening, thanks. Before you forget about us, take a second and give us a rating on Apple Podcasts and Spotify or wherever you get your stuff. Oh, by the way, 5 stars on Apple means good. We actually have a really funny 1-star review with a fantastic write-up. Best podcast I've ever seen, 1 star. I have no idea how that happened. 5 means good, 1 means bad. Don't leave us 1s, leave us 5s. Oh, Delian, how can people can track you? Twitter, LinkedIn, smoke signals? What's the best way to people keep track of Varda, what you're doing?
X.com/Zabulgar.
X.com.
We'll have to put a link in the show notes to spell that out for everyone. Yeah, that's right. It's not Twitter, it's X. We'll see. We'll see how it sticks. We'll see.
He's a great Twitter follow. I will say, can be spicy sometimes. We didn't get to talk about your tweets here, but there are a few that could have featured on the podcast.
I try to have some fun on there.
Well, thanks for your time. I really appreciate it. That's it. We'll see you.
See you guys.